Welcome to Ask and Learn.
So we have two capacitors connected in parallel. Just like this, and they happen to both be 10 microfarad capacitors. We also know that the voltage across them, this is going to be 50 volts. Now first we want to find the energy of this system. So that's going to be 1/2 times the equivalent capacitance times the square of the potential. Now the equivalent capacitance for this, well, each capacitor is 10 microfarads. So we can add the two. It's going to give us 20 microfarads. Okay, now we can plug that in. 20 microfarads is also 20 times 10 to the minus 6 farads. So I'll write that here. And we also know that there's a 50 volt potential difference. This comes out to 2.5 times 10 to the minus 2 joules. Okay, now we take one of the capacitors. I'll just choose the bottom one. And we're going to double the plate separation, so something like this. Now this capacitance is going to change. And since we know that the capacitance is inversely related to the separation distance, if we double the separation distance, that means we're going to take 1/2 the capacitance. So now it's a 5 microfarad capacitor. And now we want to find this voltage, which is no longer 50. So we know that we have to have the same amount of charge even when we double the separation distance of the capacitor. And the charge, it has to be equal. So we can represent the charge with the equivalent capacitance times the voltage, and I'll say this is 1. That's before the plate separation is doubled, and this will be 2. So now the equivalent capacitance, this is the first one. Now the equivalent capacitance is 10 plus 5. So now we have 15 microfarads. So now we can plug some stuff in. The equivalent capacitance to start was 20 microfarads times 50 volts. And that has to equal 15 microfarads times the new voltage. So V2 is 20 times 50 over 15. So now we have 66.7 volts. So the potential difference increased. Now this is 66.7. V1 was 50. And now to figure out the new energy stored in this system, let's label this again. This is U1, now this is U2. It's going to be 1/2 times the second equivalent capacitance This is CQ1, V1. Now this is 2. So this is a half times the new equivalent capacitance is 15 times 10 to the minus 6 farads. And the voltage is 66.7 volts. And this comes out to 3.3 times 10 to the minus 2 joules. So this value we get is greater than the original value, which seems like we're not conserving energy. But in order to double this plate separation, we needed to do some work. And so you take the energy stored in the original system, 2.5, and then you do work to increase the plate separation. Now you're storing more energy, and you get this 3.3, which is greater than the original energy stored. So they are equivalent if you include the work done, which is going to add potential energy to the system.